Question 7, we have a particle of mass 10 kilo attached to one end of an elastic string. Natural length is equal to 1. K is 49. And the other end is attached to the ceiling. How far will it hang freely when it's in equilibrium? Okay, let's have a look here. We have mg. M is 10, so we have 10g, or 98 newtons going down. So we have K times the unknown length, we'll call it X, minus the original length, will be equal to the force going down, my 98. If I divide by 49, I got X minus 1 is equal to 2. So the length will be 3 meters. Question 8, we have mass is 2. Natural length 2 as well, 2 meters, K7, and find the length when it hangs in equilibrium and then it's moved down a further distance. Okay, let's look at the first one. My particle, I have 2g, which is 19.6 going down. The forces up will be equal to this, which is going to be K times L minus L0. So 7 times, do we know the length? We're looking for the length, we'll call it X minus the original length 2 is going to be equal to 19.6. Dividing by 7, we get X minus 2 is equal to 2.8. So X will be 4.8 meters. Then it's brought down another bit, it's brought down another X, so it's brought down, the distance now is 4.8 plus X. And show that the force on the particle is of magnitude 7x newtons. Okay, so the force up is going to be 7 times 4.8 plus x minus the 2. Force up equals force down. The force down we've already got to be 19.6, and it's not in terms of g, 19.6. So 7 by 2.8 is also 19.6. Plus 7x is equal to 19.6. So the resultant force will be 7x newtons, which is what they're looking for. Question 9, we have a conical pendulum. A particle of mass m attached to an elastic string of natural length 3, so it's obviously gone past 3 along here. Particle rotates, so by Pythagoras we can see that this is 5. Show that it's extended 2 meters beyond its natural length. Well, we have 5 minus original length is 2 meters, so that's just what they're looking for in part 1. Show that K is this guy here, so we have some angles going on here. Call this one theta or A, whatever you choose. So let's look at our forces up and down with our angle here. So going towards P, we have K by the extended length minus the original length. And that will be its adjacent, so cos by the cos of theta is equal to mg. So we're going to have 2k cos of theta is 4 over 5 a over h is equal to mg. So to get k on its own, it's going to multiply by 5 to leave k will be 5 times mg divided by 2 times 4. 5 mg over 8, that's what they're looking for. And show the angular speed is this g over 4, or square root of g over 4. So angular speed looking along towards the center. So we're going over 2k again, this 2k. But the 2k will be by the sine of theta along this bit here. And 2k sine theta will be equal to angular speed mw squared r. So 2k times 3 over 5 will be equal to the mass times w squared times the radius the 3's will cancel. Divide by m, I'm going to get 2k over 5m. Do I have the mass? No, I just have... I don't have the mass by k in terms of m, so 2 over 5. 2 over 5 times k. 5 mg over 8. And then divided by this m will be equal to w squared. Cancel my 5 and cancel my m, so I'm left with 2g over 8, or just g over 4, is equal to my angular speed squared, which will give me the square root of g over 4 being equal to the angular speed.